Hello everyone, this is Dr. Alok Agarwal, working as an associate professor in the Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. In this video, we will be taking a topic of subject turbomachinery, having subject code ME603, which is optional subject, and we will be discussing here a power transmitting machine. Here we will be discussing a power transmitting machine, which works on the principle of hydrostatic. And one such machine is hydraulic accumulator. In previous video, we have seen how hydraulic press works and what is the function of hydraulic press. So in this video, we will discuss everything about hydraulic accumulator. So to move further, first of all, let us see what is hydraulic accumulator. Hydraulic accumulator is a energy storing device. It stores energy of a liquid and in the form of pressure energy and delivers whenever it is required by some other machine. So how it is doing? When there are certain machines like hydraulic lift, hydraulic crane, which require large amount of energy when it is getting lifted up. So this large amount of energy is provided by hydraulic accumulator. And when this lift or crane is moving down, the energy is not required from hydraulic accumulator. So at that time, with the help of a pump, this hydraulic energy accumulator accumulate or store energy in the form of pressure energy, and the liquid used here is generally water. So basically, it is an energy storing device which provide energy to a device which require high amount of energy at the time of lifting, like hydraulic lifter, hydraulic crane, and again it store energy at the time when they are lifting down where energy is not required. So how it looks like? Let us see the construction. So it has five main components. So the first one is a fixed cylinder. This is fixed cylinder, and a sliding ram is reciprocates inside the fixed cylinder. So this is a sliding ram which reciprocates inside the cylinder, and this cylinder is a fixed cylinder which holds its position all the time. Again, this sliding ram is having a heavy weight above its head, so that it will try to move, means again its natural ability to move downwards because of gravity. In cylinder, there are two slots are provided. One is for inlet and other one is for outlet. This inlet slot is connected to the pump from where water will be pumped inside the accumulator, and this water will lift this sliding ram. There is an outlet where the water will come out from this outlet when there is a requirement of some other device of high pressure energy liquid. So this is main the construction of hydraulic accumulator. So what are the components? It's having a fixed cylinder. It is having a sliding ram which reciprocates inside the cylinder by the application of pressure force. Again, there is an inlet, there is an outlet. Inlet is connected to the pump, outlet is connected to the device where energy is required, and a weight W is provided. So this weight W is altogether what is it? It is a combined weight of this ram and this weight. Means this completely sliding ram weight is W. Okay, so these are the main component and simple construction of hydraulic accumulator. Now let us see how it works. So for working, first of all, this hydraulic accumulator sliding ram component is at the bottommost position or lowermost position at the beginning. Again, at this time, there is no requirement of other device of high pressure energy, so this outlet is closed. In that case, what we are doing, we are supplying water under pressure with the help of pump inside this chamber. Once the water comes inside this chamber, it tries to lift it up because we are supplying water under pressure. So there will be a pressure force inside the cylinder, and it is acting in all direction, but this is the only movable component of this accumulator, so it will move up. Again, it will reach its uppermost position, and the water inside it Again, it is under pressure. Now, once this ram is reached its uppermost position, the supply of water will be stopped. This is closed and water is stored inside this accumulator. This water is under pressure because of the weight of the sliding ram. So, in this case, the water is having maximum amount of pressure energy because the weight is at the uppermost position. Now, whenever there is a requirement of device at high pressure energy, means any device which require high pressure energy, it is provided by this accumulator. How? By opening this outlet and supplying water which is at high pressure to the device, so that device like hydraulic crane or hydraulic lift will work accordingly. So this is how the hydraulic accumulator works. Again, let us see. It is first at the lowermost position. Water is supplied by the pump. Under pressure, it will lift this sliding ram to the uppermost position. Once it will reach to the uppermost position, it have a maximum amount of pressure energy. Again, when there is a requirement of large amount of energy by some other device, this hydraulic accumulator provides this energy by supplying water under very high pressure, because this ram is giving high pressure to this water. Once the water is supplied, the ram comes down and it again comes at the bottommost position where the cycle repeats again. So this is the working of hydraulic accumulator. Now let us see what is the capacity of hydraulic accumulator, means how much energy, how much amount of energy it can provide. So for that, what we need to do, uh, yeah, how much amount of energy it can provide or how much energy it can store, means both are same. The amount of energy hydraulic accumulator can store is equal to the amount of energy that hydraulic accumulator can provide. So let us see the expression for the capacity of hydraulic accumulator. So when we have considered a ram, the ram outer diameter and the fixed cylinder inner diameter are almost same. So let us take A as the area of sliding ram. L is a stroke, means when ram moves from bottom dead center, lowermost position to uppermost position, upper dead center, how much distance it travels. That is called stroke, or it is also known as lift of the ram. Next is P, that is intensity of water pressure supplied by the pump. So the pressure intensity which pump supplies water inside the accumulator, that is given by P. So we have seen that when pump supplies water inside the fixed cylinder of the accumulator, what happens? It lifted the ram. So again, when the ram is at the uppermost position and we stop the supply of water from the pump, what is happening? The ram will remain in its position, and that is called, we called it as a under equilibrium. So when a body is under equilibrium, the net force acting on the body will be equal or zero. The net force is equal to zero. That is, the force from top to bottom and the force from bottom to top will be same. So the force that is acting downward is the weight which is placed on the ram, or the combined weight of the uh, weight placed in the ram and weight of ram, and that need to be equal to the pressure force provided by water from downward direction, that is equal to P into A. So from here what we get? We get that weight is equal to pressure into area. Now the work done, how much work that have been done from lifting the ram from bottommost position to topmost position, and that will be equal to force into displacement. Here force means load, that is equal to W, and displacement is stroke, that our ram travels from lowermost position to uppermost position. So it will be work done will be P into A into L. So this is the amount of work done for lifting the ram, and the work done for lifting the ram is also the energy stored inside the. So this is the amount of energy stored inside the accumulator, As per law of conservation of energy, when there will be an requirement of high pressure energy, this much amount of energy will be provided by the hydraulic accumulator. Okay, so the capacity of accumulator is equal to the work done in lifting the ram. These are two equal things, and which is equal to pressure into area into stroke length. Now see this A into L, area into length is volume. So we can write it as a capacity of accumulator as pressure inside the accumulator multiplied by the volume of water that is inside the accumulator, or we can say that the volume of accumulator. So this is how the capacity of accumulator is calculated. Thank you.